And we said that chemical reactions pretty much is a process by which atoms of one or more substances rearrange to form different substances. So a chemical reaction must form something new, or else a reaction did not take place. Now, there are different types of chemical reactions, and we started looking at them. We had combination reaction. Another name for that was synthesis, where we have two reactants joining to form a single product. Then we had the opposite, which was decomposition, where you had a single reactant and it was broken down into two or more different components. Combustion reaction, where we have a hydrocarbon burning in oxygen to form carbon dioxide and water, and these are the only products that are formed. Then we have neutralization reaction, where you have an acid and a base reacting to form salt and water only. And the last reaction that we looked at is called a displacement reaction. And then we noted that there are two types. We have a single displacement reaction over here, where we can have a more reactive metal displacing another metal in a solution, or we can have a more reactive non-metal displacing another non-metal, which is less reactive, in a solution. And then we had double displacement, which is also called ionic precipitation, where we have exchange of ions. Now that we have that, right, we are going to now learn how to balance these different types of reactions. Now, to balance reactions, ladies, I'm going to show you one method that I use that is sort of foolproof, meaning that it cuts down on the error when balancing, and it helps you to do it a little easier and a little quicker. It is not the only method that is out there. Some persons are able to do it otherwise, right? I'm just presenting one to you. So the method runs down like this. One, if you're given the worded equation or you're given the scenario where they tell you what is reacting, you're going to write down the reactants and the products in the form of a chemical equation, meaning that you use your chemical symbols, right? Your reactants are separated by a plus sign, and then your products are after the arrow. So there are two sides of the equation, reactant side and your product side. The next thing that you're going to do, right, is to list all the atoms that are in play. So you're listing all the atoms that are in play. After you have done that, you're going to list, or you're going to count up how many of these atoms are on the reactant side and how many of those atoms are on the product side. Then you are going to start balancing them by putting what is known as a coefficient in front. Those coefficients are those numbers that you're seeing in front of a reactant and or the products. All right. Now, if you have reactants that contain hydrogen and oxygen, there is a recommendation. The recommendation is this: balance all the atoms first, all the other atoms first, do a hydrogen second to last, and oxygen for the very last. So that is what the suggestion is. So for example, in this reaction here, this is a hydrocarbon reacting with oxygen, and this is a combustion reaction. So notice that we have carbon, hydrogen, and oxygen atoms in play. Now, if we were to start balancing this, we are going to start with carbon. Then next, we're going to move on to hydrogen and then oxygen for the very last. All right, so let us do some working examples now. All right, so what I've done is actually give you the worded equation list because we still need to practice writing chemical equations, all right, and writing our chemical formula. So I need a volunteer to help me write the chemical formula for these reactants and products. So we have magnesium burning in oxygen to produce magnesium oxide. Who is going to help me with that one?
Me, miss.
Go ahead.
So we're going to have Mg2 plus O2.
So Mg plus O2, yes, and what is that producing?
Miss Mg. Miss
So
MgO.
Excellent. So we need magnesium oxide. No, so don't spot it up with the 2 now. All right, so rough work column, ladies. Magnesium is in group 2, so it's 2 plus. Oxygen is in group 6, and their valencies are 2 minus. What do you notice about the charges?
They are the same.
They are the same, meaning that they're balanced. So it means that we just write one atom of each. So it is MgO. All right, lovely. Now I'm going to show you my working out method. So this is to start you off. Eventually you can wean yourself off doing this, ladies. All right, so what I have is a table that shows reactants and products. In my extreme left column, I'm going to write all the atoms present. So right now I have magnesium and oxygen present. So I'm going to count them up now. How many magnesium on the reactant side? How many on the product side? So let's go. On my reactant side, I only see 1 magnesium. So I write the number 1 here. On my product side, I see 1 magnesium again. So I write 1. For oxygen now, so I'm finished with this. For oxygen now, when I'm looking at the formula, I see O2. The subscript 2 tells me that I have 2 oxygen atoms. So on my reactant side, I have 2 oxygen atoms. Now I'm on my product side. There are no subscripts, and so in my formula, I see 1 oxygen. Now, when I do a table like this, ladies, immediately I can tell you which ones are unbalanced. Magnesium has 1 atom on both reactant and product. So guess what? Magnesium is balanced. Oxygen, on the other hand, look on it. I have 2 on my reactant side and 1 on my product side. Now, for balancing, ladies, the only way to balance is to write what are known as coefficient. Those are my numbers in front. So guess what? I can only put a number here, or a number there, or a number here. I cannot change the chemical formula for any substance. So guess what? I can't put a number here and put Mg2. I can't change the 2 that's there and put a 4. This is wrong. I can't put a number in between my formula, like a 2 here, so that it can be balanced. That's wrong. So I can't change my chemical formula. Remember that formula, they are specific for each compound, so I can't change them. So the only thing that I can do is to write numbers. Those coefficients work as multiples. So I can only write a coefficient or a multiple in front of either my reactants or products. Sometimes I need a coefficient in front of all of them. Sometimes I don't. Sometimes it's just 1. Sometimes it's only on the product side alone. Sometimes it's only on the reactant side alone. But whatever the case is, I need to balance off these atoms. Now, why do I need to balance an equation? Why am I going through all of this, ladies? The reason is because of what they call the law of conservation of matter. So some of you may have heard the saying that says matter is neither created nor destroyed. All right, it's the same thing here. If I am starting off with, let's say, for example, 5 of a particular atom, what the law is saying is that whenever it forms products, it doesn't matter how many products it's going to form, I must still have a total of 5 because matter is not destroyed. So it's not disappearing anywhere. Even if it forms a gas and it is escaping into the atmosphere, it must be the same number of particles that are escaping. So they're not disappearing or going anywhere. They are being transformed into something new, a new product. So the number of atoms must remain the same. So let's go with balancing this equation now. Magnesium is okay, and so I'm not going to trouble magnesium. I need to now look at oxygen. Oxygen is off. I have 2 on my reactant side, 1 on my product. Where and how can I make a balance for oxygen? Anyone wants to take a guess? Do I need to balance my reactant side, which is this side, or my product side?
It's the reactant.
Reactant.
All right, so the reactant is over here. I have 2 reactant, and the product is on this side, which is 1. Which one do I need to balance off? Look on it. Look on it. Which one is off? The product side is off. So
Mr. Product side needed to.
right. So the product side needs 2 atoms of oxygen to balance off this 2 on my reactant side. But what is happening now? Can I do this? MgO2?
No, miss.
No, because the formula must be the same. So I can't add a subscript. So this is what I'm going to do. I'm actually going to add my coefficient. So a coefficient to turn 1 into 2 is to actually multiply it by 2. So now I have 2 oxygen. So this is where it's a multiple. That's why I say it's more like a multiple. So see there, I now have 2 oxygens. But what is the problem now? If I write a big 2 in front of MgO, what else is being multiplied by 2?
The Mg on the reactant side.
Exactly. So guess what? Me putting a coefficient actually affects all the atoms in a formula. So right now I have 2 over here. So oxygen is quite okay now. But I cannot do something now. Magnesium, because I put 2 in front, is now 2 on my product side. It was 1 on my reactant side. So tell me, what is it that I need to do now to balance off magnesium? Because I just threw magnesium out of whack.
Miss, put a 2 in front of magnesium.
Very good. So I'm going to put a 2 right here in front of magnesium to signify that I have 2 atoms of magnesium now. So look at this. I now have my balance. See there? So my table shows me that I have 2 magnesiums on either side, and I have 2 oxygens at either side. So that's how we go about balancing. All right, give you 30 seconds to soak that in. All right, let's move on to the, oh, by the way, what type of reaction is this, please, ladies?
It's a combination reaction.
Miss
Very good, very good.
Combination.
So this is a combination. Give me another name. Starts with S.
Miss Synthesis.
Excellent, ladies. Excellent. Synthesis or combination reaction. Very good. All right, let's look at this one now. Now we have nitrogen gas reacting with hydrogen gas to produce ammonia. All right, how do we write nitrogen gas? So remember, a lot of these gases tend to be, when it's the same atom, they tend to be diatomic in nature. You remember what diatomic means?
Miss, it means 2.
Very good. So what's the symbol for nitrogen?
N2.
Nice. So nitrogen gas is N2. All right, that is reacting with hydrogen gas. How are we going to write hydrogen gas?
H2.
H2.
Excellent, ladies. And then this is producing ammonia. Anyone remembers the formula?
Miss NH4.
Close, close. It's actually NH3. So N2 plus H2 produces NH3. Nitrogen plus hydrogen gas produces ammonia. All right, so going from our rough work table now. All right, now I need to identify the atoms that are present. What are the atoms present in this reaction?
2.
Miss nitrogen.
Nitrogen and hydrogen. Very good. So only 2, nitrogen and hydrogen. Then I'm going to identify how many on each side. So I have a subscript, ladies. I remember the subscript tells you how many atoms are there in the formula. So how many atoms of nitrogen on my reactant side?
2.
Very good. How many on my product side?
1.
1. Excellent. So I have no subscripts, no 2, no 3, no 4. So I only have 1 atom in the formula. Hydrogen is easy, it's 2, but how many on my product side?
3.
Nice. All right, look at this table now, ladies. Is there any atom that is balanced? Reactant side and product side?
No, miss.
No.
Miss.
So guess what? We're gonna have to balance each of them. Now, this is where the suggestion comes into play. If you have hydrogen involved, leave that for either last or second to last. Balance the others first. So we're gonna balance which one first?
The nitrogen.
The nitrogen. Very good. Now, as a reminder, I'm just putting these here. Remember, I can only put coefficients or numbers on my yellow line. I cannot change the formula of any of these to suit me. I can't make it easier on myself by just switching up numbers. All right, so let's go. We have nitrogen that we're going to look at first. So 2 is on the reactant side, but 1 is on the product side. What coefficient I'm going to use to make it balance?
What is in here?
Nice. I'm going to use 2. Am I going to put the 2 on my reactant side or my product side?
Miss the product.
Excellent. The product side. So now I have 2 nitrogens. So nitrogen is balanced. Now putting the 2 as a coefficient in front of ammonia, what else did it affect?
Miss the hydrogen.
The hydrogen. Excellent. So now remember, originally we had 3 hydrogens and now we're doubling it. So how many hydrogens do we have now?
6.
6. Excellent. Now we need to look at the new numbers. I have 6 on my product side and 2 on my reactant side for hydrogen. What coefficient could I use on my reactant side to balance this off?
Miss 3.
Excellent. 3. So this is my reaction. N2 plus 3 H2 or 3 hydrogens produces 2 molecules of ammonia. So this is now 6 and we are balanced. Excellent job, ladies. All right, now always throwing it in there. What type of reaction is this?
It's combination.
Very good. It's another combination or synthesis. All right, let me see what's our next one. Or do you need the seconds to soak it in? Anyone not seeing or not understanding? You need to speak up, ladies. Beautiful. All right, look at this now. This one is longer. It says iron reacts with sulfuric acid to produce an aqueous solution of iron 2 sulfate and hydrogen gas. Wow. So this is just throwing it out there first. Iron reacts with sulfuric acid to produce iron 2 sulfate and hydrogen gas. All right, let's see who's on the ball. What's my formula for iron?
It's Fe.
Nice. So Fe is the formula for iron. Now, because it is just iron, which is a metal, ladies, we just write the symbol. It does not have the subscript 2 below it, and you do not write the charge above it. All right, it is just Fe. Very good. Sulfuric acid, anyone knows the formula?
It's S.
H2. Yes, there is an S. O4. All right, we soon reach acid and bases where you learn all of them. All right, so Fe plus sulfur give me iron 2 sulfate. Boy, I don't know this one out of my head, you know. So I'm going to do a rough work. When I see the word metal followed by my number in Roman numerals, ladies, you know what that does for me? It tells me what the charge on the metal is. All right, beautiful. So if I have Fe and I see 2 and I know it's a metal, then the charge is going to be 2 plus. Easy, easy. So iron 2 lets me know that it is Fe 2 plus. And then I need to know my charge for my sulfate. It is 2 minus. Now, what do you notice about these charges?
They're the same.
They are the same. So if they are balanced, I only need to write one of each. So I write 1 Fe and I'm writing a little better for my sulfate ion. And that's the formula for iron sulfate. Now we need to write hydrogen gas. How do we do that?
It's H2.
Nice,
H2.
nice. All right, so we need to balance. So let me show you. Eventually, ladies, you can look across, meaning that you're reading across this way. So I can say, okay, 1 iron, 2 this, 2 that, and you go across. We don't reach that stage as yet. So we're going to draw our table, reactant and product. Now, what are our reactants and products now? What are our atoms that we have? So we have iron, we can see that. What else is there?
It's hydrogen.
Hydrogen, very good. Anything else? Come on, you're leaving out, man. What else?
It's sulfate.
Nice. All right, now I'm just going to point out something to you, ladies. When we have our polyatomic ions, sulfate, nitrate, phosphate, carbonate, and the list goes on. If they repeat on your product side, meaning that I see a sulfate here and I see another sulfate there, and it is not split into sulfur and oxygen, then I can count it as 1 unit. All right, so let me repeat that for you. If ladies, there's a case where you have polyatomic ions and they are the same on your reactant side and your product side, then you use it as one unit. However, let's say, for example, you had sulfate on this side, and then on your product side, you're seeing sulfur dioxide forming instead, or just sulfur forming instead. Then we're going to have to split it and look at sulfur separate and oxygen separate. But in this case, we have sulfate present, so we can look at it as one unit. So let's do our counting. Fe, I have one on my reactant side. Look at my product side, I also have one. Hydrogen, in my formula, I see H2, so I know I have two hydrogens. And then H2, let me, right, so the H2 there, so I have two here. Sulfate, one each. What are you noticing from the table?
Miss, all of them are balanced.
Nice, nice. So that's something else for you to look out for, ladies. Not all reactions will require you to put coefficients, all right? So some of them are balanced, just like how you wrote it. But guess what? You have to check, have to double check that that's the case. So right away, if I look, once I do my table, I can see it that it is balanced. So I am good and I leave it as is. All right, anyone wants to take a guess at what type of reaction this is?
This displacement.
Nice, it's a displacement. And because I just have one metal displacing hydrogen, it is known as a single. Nice, very, very good. That is it. All right, I think we can squeeze in one more example, and then I'm gonna set you off with some work. Let me see which one. Eeny, meeny, miny, moe. Let's do this one. All right. Propane, they gave it a formula because of course you don't reach organic chemistry as yet. So C3H8 burns in oxygen. Propane, this is what is in your cooking gas cylinder, you hear? So when you're cooking on the stove, if you have a gas burner, this is what is burning and producing that wonderful flame for you to cook. All right, now immediately you can tell what type of reaction this is. Who wants to take a guess at it? What type of reaction?
Miss, neutralization.
Close, close, but we have the water, but not a salt. Look at what it is reacting with. Someone just said it. Very, very good, honey. So this is actually combustion reaction. So your hydrocarbon burns in oxygen to give you carbon dioxide and water as your only products. All right. Woo, let's go now. Reactant, product, and we need to highlight what's there. So for a reaction like this, ladies, all right, my fifth formers like to call it CHO, all right, CHO. So let us go now. We have how many carbons on my reactant side?
3.
3. How many on my product side?
2.
Look on it.
1.
1. Very
1.
good. How many hydrogens?
8.
8.
How many on this side?
2.
2. Very good. Oxygens?
2.
2.
And oxygen and oxygen. Oxygen and oxygen. Look at it. How many in total?
3.
3. Very good, ladies. So I have 2 in carbon dioxide and 1 in water. All right, is anything balanced here?
No, miss.
Not at all. So guess what? We're going to have to do some balancing. Again, now this is where the suggestion comes in. Balance the carbon first, then hydrogen, then oxygen. Now, even if we have the numbers changing because the coefficients are going to affect the other atoms, you know, still balance them in the same order. So let's go with carbon. What side do we need to fix? Reactant or product side?
Product.
Miss Product.
Product side, nice. What coefficient do we need to write?
3.
3.
Three.
Excellent, excellent, excellent. Now, this 3 is going to affect what else? My oxygen, see there? How many oxygens do I now have? 3 times 2 is what?
6.
6. But guess what? Remember this one over here? So now I have 7. Now, because they say leave the oxygen for last, leave it alone. So don't trouble anything down here. So don't bother change up any numbers. Let's go to hydrogen. I had 8 on my reactant side and 2 on my product side. So what coefficient am I going to write?
4.
4. Very good, because 2 times 4 is 8. What does this 4 also affect, ladies?
The
Miss
oxygen.
The oxygen. Good. So you see why they say leaving oxygen for last? Because oxygen tends to get messed up a lot. So let us now add how many. I have 3 times 2, which is 6, plus 4 times 1, which is 4. So I no longer have 3, but have how many?
10.
10. Very good. Now I have 10 on my product side and 2 on my reactant side. So what coefficient do I need to write here?
It's 5.
A 5.
5.
And
5.
that is it. That's my balance equation. That's it.